Mr. Beak's math class. Mr. Beak's math class. Yeah! Woo! All right, everyone, welcome. It's 2.2, day 2 on adding and subtracting inequalities. Okay? Hopefully by the end of the day, we're getting more comfortable and we can say that with confidence, I can solve by adding and subtracting inequalities. Okay? Real quick reminder on the graphing. If we have less than or greater than, that is going to be an open circle when we shade a certain way. And if I have less than or equal to, greater than or equal to, that's going to be a closed circle when I shade a certain way. Okay? Talking about our learning scales. Hopefully we're at the 3 or 4 range, or at least getting there today with some more practice. All right? I'm going to just open it up into a little bit trickier problems where we left off. I'm going to get those out of the way, and I'm going to just draw my own stuff. So first off, number 5 up here. When I'm solving these, I solve it just like a normal equation where I draw the line right down the middle. And I want to get all the variables to the same side. In this case, my variables are on the right-hand side, so I'll just keep them on that side and deal with it as it comes. Okay? I see I have a 4c minus 3c. Well, 4 minus 3 is 1, so 1c plus 10. Okay? And all that stuff in 12, right? So if I want to get c all by itself, well, notice 1c is the same thing as c. So I'm basically already there. I just have to minus this 10 to both sides, and I get 2. Okay? Which leaves me with the question, what should my sign be, and how should I graph that? All right? Well, if I'm adding and subtracting, it's all I did there. The sign will stay the same, and so that's my graph. It says 2 is less than or equal to c. Well, if I have to graph that, 2 is right here, means 1's smaller, means 3 is bigger. I don't even have to do any math. I already know that that's going to be a filled-in circle, a closed circle. And usually I like my variables on the left-hand side. This one is on the right, so it's actually going to be kind of the opposite shading of that one, which is this one. It says 2 is less than c, or another way of saying that is c is bigger than 2, and that's how we get our answer. Okay? All right. I think I'm gonna skip ahead to the next slide. You can look at that. Here's a real life example. I understand there's a lot of words here. This is our main thing that we'll just read. But a circuit overloads at 1800 watts. That's the most you can have in your circuit for electricity. You plug in a microwave that already uses up 1100 watts. Okay? Side note, this happened to me in my house. We bought a new fridge and we bought a new microwave and dishwasher and all that stuff. And our new ones were too powerful. And it shut down all the stuff in our whole house, and we were freaking out. And we're like, why is this happening? Because we had to rewire our stuff. But so anyways, this one says to write and solve an inequality. All right? How many watts can you add to it? Well, I'm just gonna show my work right here, even though it's for letter A up there. But we need a variable, right? Whenever we have an inequality, write and solve. So here's how I would say this. Our oven uses 1100 watts, right? 1100 watts plus something, right? And the maximum that I can have is 1800 watts, right? And we just need some sort of inequality sign right here to decide for what's going to go in there. Right, and solve an inequality, how much I can add to the circuit. That's why I added right here. Okay? And so what is my sign going to be there? Well, can I go over 1800? No, I have to have less than 1800. But could I have right up to 1800? Yes. It overloads. Actually, it says it overloads at 1800. So that means 1800 would zap those things. So it's going to be like that. All right? That is my inequality. That's my answer for letter A. I'll just put that there. So for letter B, it says, in addition to the microwave, what appliances could I plug in without overloading it? Okay? Well, if I wanted to just quick solve this, you can probably think and just realize, hey, minus 1100, I can add less than 700, because 1100 plus 700. So if I add anything, 700. So what does that mean I could add? Well, it means I could add a clock or a blender, excuse me. That's 300. I could add a toaster. I could add a couple clock radios. Couldn't add one of those hot plates, right? And so there's a lots of options and stuff like that. I could add 2 blenders. That'd be 600 and 2 clock radios, right? So lots of options. I'm just going to leave it at that for our explanation, okay? And I'm going to just skip that. Who cares? All right. I probably shouldn't have said that on video, but I want to make this a little bit shorter, okay? So this one says I have 15 bucks to spend on inequalities, on groceries. I have $12.25 worth in my cart. All right, let's write an inequality for that using M. All right, well, if I have $12.25 plus M, if I have to have that be 15 bucks, that's how much I have. I could spend 15 bucks, so that's the or equal to. I could not spend more than 15. So I know it's got to go the other way, right? I could spend $14.99. That'd be fine. I could spend all the way up to 15 bucks. So that is going to be my inequality there. And then when we solve it, we're just going to minus this 12.25 to both sides and get our final answer. Okay? So M is whatever that number is. Okay? So that's how we do it. Kind of problem solving a couple of those. Last couple. Okay? Sometimes we see decimals and we freak out. It's not any different than other stuff, right? If I have a plus, what's the inverse of plus? Well, it's minus. So I'm going to just minus 3.8 to both sides. Minus 3.8 to both sides. Okay? And if I'm adding or subtracting, I shouldn't have to change the sign. So you just have to make sure you type in right on your calculators, -9 minus 3.8, which gives us negative 12.8. Okay? Real quick refresher on the graph it. I'm gonna put negative 12.8 on there. Now, people might freak out on the graphing part of this. Well, what's one less or one more? You got options. You can do negative 13.8 and negative 11.8. That's fine, right? And so this one's going to be a closed circle. Why is it closed? Because it's got the or equal to. And it's less than or equal to, which is all these ones. Okay? So that's going to be my final answer there. And then the last one, fractions. Kind of the same thing. If we have decimals, those are tough for a lot of people. If we have fractions, they're tough for a lot of people. All right, well, if I said x minus 3 equals blah, 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 you would just add 3, right? It would be no big deal. So this one, I have a negative 3/4. I'm just going to add 3/4, right? And that's going to wipe out in one fell swoop. So if I do that same thing to both sides, I'm going to have x, I'm going to have that sign, and I'm going to just have to type in on my calculator 2/5. Let me do that. And then plus 3/4. And what do you know that we get? I got 23/20. Ooh, that doesn't look very nice. But we're going with it. That's the right answer. We did the right steps. And so if you had to graph that and we're putting 23/20, well, what's one less than 23/20? How about 22/20, right? No big deal. Or 24/20. Okay? So you don't have to make these super complicated like that. Now, as a mathematician, side note, we can reduce that down, right? I could divide by 2 and you'll get 11/10. And on this one, you'll get 12/10, right? Oh, wait, I can do that again, 6/5. So, I mean, like, technically, that's the chain of numbers. But I don't care. If you do the green ones, that's fine. As long as I'm more worried about just like getting the circles right. And this one's going to be an open circle because it's one of those. Okay? And this is 23/20 is bigger than x, so that means x is less than that stuff. Okay? Real quick second day for you, but hopefully it's becoming a little bit more clear. Thanks. Take care.
Mr. Big's math class. Mr. Big's math class.